How are you? Huh? Hi. So it's not good morning. so, so my name is Moses. I am a blockchain developer. Also, I'm a Web3 JS ambassador here in Kenya. So today I'm going to take you guys through the basics of blockchain. So we'll start from the evolution of internet up to what is blockchain and get to know what this is. So I'll just like to know, like, maybe uh, who knows what Web3 is? Just by show of hands, Web3, if you have heard about Web3, by show of hands. Okay, who was that? Okay, one. Okay, do you know about anybody who knows about crypto? Maybe maybe you guys know about crypto. Anybody? Oh, so you guys are traders, right? Okay, so okay, crypto is just a tip of what it's just a tip in Web3. Uh, okay, so I'll start with the evolution of internet. So at the beginning, we had Web3 1.0. So not Web3, as in Web. Is it the evolution of the internet? Like we have the Web 1.0, then we had Web 2.0, and then Web 3.0. So Web 1.0 basically means it's whereby, yeah. So Web 1.0 basically is like we had static sites, like you couldn't interact with them. So you could just go to a site, just like uh, go through it, and you can't interact with it, and yeah, it's just you just see you could only see the contents on uh, the application. So for Web 2.0, it was a bit of an evolution from Web 1.0. So there were some features that were added. So you could interact with the web. Like let's say, for example, you go to let me give an example. Like let's say, what app do you use to shop? Mnaodanga pizza na nini? Yeah, Glovo. So you can, when you go to Glovo, you can order food, right? That you're interacting with the application, right? So that is somehow how Web 2.0 became a difference from Web 1.0. Web 1.0, you could only just read. It's only read, but for Web 2.0, it is read and write. So you can input your details, you can interact with it. Hope you get that. And now we come to Web 3.0. Okay, Web 3.0 is kind of Web 3.0 is kind of different because it is decentralized. Now it brings in the feature of decentralization, meaning that it is not controlled by a central entity or organization, meaning it is decentralized. No one controls it. Hope you get that. So that's how the internet evolved from Web 1.0, Web 2.0, then to Web 3.0. Okay, so we are going to look at now blockchain, what blockchain is. Maybe who knows what blockchain is? I need someone different, not you. I don't know. Do you have some matches? Maybe guys need to be motivated a little bit. Who knows what blockchain is, or can give a try to maybe a guess? Okay, nobody. So okay, you can give it a try. Okay. Okay. You're almost there. It's a ledger, then. Uh-huh. Yeah, you're actually right. That's what blockchain is. It's a decentralized ledger, meaning that it's just a ledger like those guys who did business in high school. For me, didn't do business. Know what ledger is. So it's a decentralized ledger, and as you said, no one when making a decision, like it's distributed to among many computers, right? Yeah. So that's what, as he has explained, that's what blockchain is. And there's another part, let's say smart contracts. So I don't know what's that about smart contracts. You have, you have also. So what, can you maybe give us your definition of a smart contract? Yeah, smart contract. A contract that is smart. Yes. Ah, nice. Can you tell us your definition of a smart contract? Ah, nice, nice. That's a good definition. Anyone else who has an overview of what a smart contract is? There's no one. Okay. She has given a very good definition. Also, you're kind of right. So, a smart contract is a, let me say, it's a set of rules that are programmed in that when a certain event occurs or a certain event is fulfilled, sorry, if a certain event occurs, uh, there is, okay, let me say it in this way. It's a programmed set of rules in that if what is it is been has been defined there is fulfilled, then the smart contract is executed. Like, let's say I give you this pen and I tell you, only give this pen when this guy comes for it. So when this guy doesn't come for this pen, you won't give it out. You only give it out when this guy comes. So it's a set of programmed rules that are executed when a certain condition is met. Yeah. Okay. So let's move to tokens. Huh? So who has heard about tokens? What, maybe do you know what tokens are? Okay, there's a difference between tokens and coins. Okay, let's start with tokens first. Nice, nice. Any other? And what about a coin? Uh, it's backed by. Okay, you are bringing another concept of a stable coin. Okay, so okay, a token. Okay, there's a difference between a token and a coin. So for a coin, it's a, how do I put it? It's a digital asset. Majorly, it's usually a native one. Huh? Like, let's say Bitcoin. Bitcoin is a coin. Bitcoin, and there's the Earth. The Ether, I don't know, it's Ether or Earth. It's also a coin. And there's a token now. Now a token, it depends on, it's built on a, let's say, on top of a blockchain. Like, let's say most L2s. Let me give an example of Link, the chain link, the coin called Link. That's a token. And there's also how do you call it? Maybe Uniswap. The Uniswap has a token called Uni. That's a token. It's built on top of it. It is in the, it depends on a certain blockchain. It's built on like, it's kind of built on a blockchain. It's not native, no? Yeah, that's what we call a token and a coin. A coin it's like Bitcoin. Bitcoin has its own coin. There is Ethereum, like Solana. Solana, there is the Sol. That's now the coin. So there's a difference between a coin and a token. Yeah. So to talk about stable coins, huh? Stable coin is a okay. It's a coin that is backed up by the US dollar. In that, let's say you have one maybe let me give you an example of a coin. Let's say you have one USDT. USDT is it's a stable coin. So one USDT is equal to one US dollar. Like it's 100% backed up by the US dollar. So when you have one USDT or one USDC or also DAI is also a stable coin, right? Yeah. So if you have one die, as in it is usually backed up by the US dollar. So like it doesn't depreciate or lose value. Like let's say most coins you can find like today Bitcoin is at this price. Tomorrow you'll find it at a different price. So to try curb that, they came up with a stable coin. So that's mostly used to maybe to do transactions, maybe come on maybe if you are buying something using you want to buy something using crypto, it is usually advisable to use stablecoins. So another thing maybe I can talk about is dApps. Who has heard about dApps? Yes. What's the dApp? Yeah, that's a decentralized application. Now, what is it? Because for a dApp, as in I've just shortened it, uh, like dApp now decentralized application. What is a decentralized application? Yeah. Oh. Also, can you give us an example of a dApp that you use? Maybe if you do, you don't use dApps. You don't. Oh, okay. Sorry. If you don't, it's okay. Okay, so as she has said, adapt is an application. Like normally we have applications, decentralized ones, like maybe M-Pesa, that's an application, it's a centralized application. Now, the decentralized applications that are built on the blockchain are called dApps. So an example of a dApp that I've used, maybe you can say, mostly I use centralized ones. Uniswap, there's Hmm. There are a lot of them, but mostly I interact. No, most of them nowadays are the kind of hybrid, centralized. Like is Binance decentralized or centralized? The Binance app, yeah, kinda. So it's kinda a bit difficult to determine whether an app is decentralized because the like maybe it is decentralized and then it is centralized. Then they put in maybe they decide to put in the decentralization in some features, so it's not fully decentralized. Yeah. So that's what adapt like. We have also DeFi's. DeFi is decentralized finance. So like most dApps are okay. Most DeFi's are dApps. Yeah, decentralized finance apps. Like let's say what for Nexus. Oh, do we have anybody from Nexus Pay here? Don't know if it's decentralized or centralized. There's an app called Nexus Pay. There's also which one? Let me see. I must have a decentralized app here. Pretium. I don't know if these dApps are decentralized or centralized. They kinda yeah. The World app. Let me give a good example of World app. Those who have world coins. Do you have those guys who have world coins here? Rich kids. You don't have WorldCoin. Yo, okay, so WorldCoin it's a decentralized app, right? Yeah. So for those who have WorldCoin is an example of decentralized app. Yeah. So I'll also talk about DAOs. DAOs is a decentralized and autonomous organization. Like let's say, for example, these are organizations that are, let's say you want to make a decision within an organization. So they usually develop DAOs whereby the decision that is made within that organization it does not come from a central entity or from a single person. Like uh, everyone has to agree on what to on decisions. No, like you don't make a decision on your own. So that's what you call a uh, decentralized autonomous organization. Yeah. So if you noted anything down, you can go do research about it and maybe expound on that. Yeah. So thank you guys. Uh-huh. Yes. Oh, we have non-fungible. Okay, we have fungible tokens and non-fungible tokens. So for fungible tokens, we can say they are like, I don't know if you know about ERC20. Okay, for fungible tokens, fungible first means like it can be broken down uh, into what? Into small, yeah, smaller equal functions. So for NFTs, I don't know. For NFTs, it's kind of different. It's not like it can't be broken down into like fungible tokens. So for NFTs, let's say for example, you have let me just give an application of where it is used. Like, let's say you have your art. You can have a digital representation of it, like on the on chain. Like let's say you you, it's given a unique ID. So that unique ID is it's a representation of your art. Mostly it's used in art, in maybe in tokenization mostly. Like maybe you are tokenizing a car, like you have to make it like you can't store the real images on blockchain. It's kind of expensive, so you have to store it using the those NFTs. So like let's say it's that asset is given a unique ID. So that unique ID is what represents that asset. Yeah, that's why now the NFT concept comes in. Yeah. Sorry, a JPEG file. Okay, so for that JPEG file, for it to be stored on the blockchain, like it's kind of very expensive. So you can't store it as a file that way. So you'll have to like give it a unique ID. So this unique ID is what is represented as an NFT. So like let's say you can mint it, you mint the ID, you don't mint the exact let's say the exact uh, JPEG, the image itself. You know, like it's expensive to store images on blockchain. Yeah, so it's the idea that is stored on the blockchain. Yeah, yeah. Thank you, guys. Yeah. Oh, sorry.
Okay, I see that you're really engaged people. That's really good. You're not as shy as Jaquad and Setek. I really liked the environment here. Something that I started to notice is that it's better to come here and based on what you know and what you want to learn, do the presentation and the workshop based on that instead of me bringing a prepared presentation. And it's been working really well that way. So today, I think to start, I would like to know who understand the concepts of the different blocks in the blockchain. Who don't know that? Who don't know the concept of the blocks and what is the block contains in the blockchain? Perfect. So then let's start with that. The first thing that you need to know is that there is something called block explorers. So for us to be able to understand what's going on in the blockchain, we need to go to these block explorers. And then in the block explorer, we can see what's happening, right? So the block explorer of Ethereum is called Etherscan. And then there is one block explorer for every blockchain. So if you go to, let's say, Bitcoin block explorer, it should be one here. Yeah, like for example, this one. And then you can see what's happening in every block. Same with Arbitrum, Polygon, etc. Every blockchain will have their own block explorer. The one that we are going to focus today is Etherscan and Sepolia Etherscan. So Sepolia is the testnet of Ethereum, in the one that we are going to write a smart contract and deploy it in Sepolia. And then, for example, something that you need to know is that in Ethereum, the blocks are minted every 12 seconds. So every 12 seconds, we will have different blocks here. And then in a block, we have a lot of transactions that are stored. So that's what is stored in a block. So in a block, let's say that, for example, I sent 1 million of shillings to Moses. So that will be stored in that block. And then that block will be connected to the next block by something that is called the block, where is here? The block hash. Oh yeah, the hash and the parent hash. So let me just do like a little, let's see if there is something here, blockchain diagram. If not, I will create something in Paint really quick. Oh yeah, there is something here. So what happened with the blockchain is that we have blocks, and then these blocks will store a lot of transactions. That's what happening in the blockchain. But then when we store all these different transactions, there is something called hash. Who don't know what is a hash? Okay, something new to learn. So the hashing function that is used in Ethereum is called Keychack256. And this hash, basically what it does is that it will give you an output that is unique regardless of the length of the input. So for example, if this hash, I want to put my name. So the hash of Santiago as an input is this output. And always the output, I think if I'm not mistaken, this is 32 bytes length. But then if I just put Santiago with a lot of O's, you can see that just do a little bit closer. You can see that the output is always 32 bytes length. So what happened in the blockchain is that what is stored in the blocks is just a lot of transactions. So let's say Santiago sent 1 ETH to Moses. This is transaction 1. Then Moses sent 2 ETH to Gideon, etc. And then we have a lot of transactions. And then these transactions, as you can see, are just being stored in the block. And then we will have a hash. This hash is unique for every block, because you can see if I just change one dot, the whole hash is changing. You can see that I just put a new dot and everything is changing here. So when we have all these transactions, we are going to hash everything, and then that will be called the hash of the block. Where is my image? The hash of the block. And then when we have one hash of the block, the next block will be connected to the previous hash. And then that's really important, because we cannot modify anything in the past, because if we modify the hash of this block, let me just take a screenshot to make it maybe easier to understand. Okay, so let's say that the hash of this block is, okay. Okay, so let's say that the hash of this block is 0x123, right? Like we put a lot of transactions. Remember that the hash is 32 bytes length, but we just put 1, 2, 3 to make it easier to understand. And then we have 5 transactions. 5 transactions here. Transactions. Okay. And then what happened is that the next block will have the previous hash, the previous hash of this block. Let's say this is block number 1. Block number 1. Yeah. And then this is block number 2. And then if someone tries to do like a malicious attack in the blockchain or whatever, and then they change one of these transactions that was sent here, this hash will change. This hash will change. And then if this hash change, this hash will not match the previous hash, right? And that's why the blockchain is really secure, because that what already happened in the past cannot be changed and will be stored there forever. So we can check like maybe 10 years ago when someone sent the first transaction, and that will still be there. Let me actually, let's see if that exists. So this is the block right now, 207911629, and this is the timestamp, September 20, 2024. And then if we check the block number 1, let's see what happened. It was, okay, 3,339 days ago in July 30 in 2015. And then we can see what happened in this block. We also have the hash and the parent hash, and then everything is starting from this block with this hash. And then the block number 2 will have the previous hash and so on. And that's why the blockchain is kind of secure, because what happened in the past will be there forever. Any questions with this so far, with the blocks and the hashing?
Just wanted to clarify. So where does the previous block hash go in the next block? Does it go in the block as part of like the transactions, the transaction hashing? Is it like intermediate out?
Okay, that's a good question. So where the previous hash of the block goes, there is something called block, I don't know if that's called like the block information. That should have a name, but I forgot the name of that. And it's just in the, okay, that's block header. So that's in the block header is to store all this information of all the transactions, all the hashes, the timestamp, everything is in that block header. So when we, for example, get a block, let me actually also do something new here. I'm going to create, maybe I don't wanna do code yet. Yeah, but I'm going to show you in a block. If we try to get the information of the latest block, we'll get all this information. That is the validator of the block reward, the gas used in that block, etc. But that goes in the block header. That's called block header. So all this thing that you see here is block header. The hash, previous hash, transactions, etc. Perfect. Any questions with this part? Okay. So now you know that the most important thing is the block explorer, because here we can see everything. Now, who don't know what is MetaMask or accounts in blockchain? Perfect. In blockchain, we need to have accounts, because those accounts will have money, right? Let me actually create something here. I will upload this to GitHub. And maybe let's start with a README to put some information here. Okay, so first thing is accounts. So in blockchain, we will always need accounts, and an account will always have a private key and an address. This private key is like the password for you to be able to access to this address. And this address is like when you have your bank account, you can tell your friends, hey, send me your M-Pesa number. That's the perfect example. This is your M-Pesa number, and then this is the password to access to your M-Pesa. You don't have a password in M-Pesa, but something like this. So if you give this password to someone, that someone will be able to access to your M-Pesa, and then they can get your funds. So that's why it's really important to keep your private key private, and then you can share your address with everyone. And then MetaMask is just a browser extension. You can use it in Brave, Chrome, Firefox, etc. That will allow you to have accounts. In this case, I have a lot of different accounts here. Then you can put a different name. I will create a new account just by clicking here in Add Account. Then add an Ethereum account. I will call it CUEA here, and then I just created an account. And this account will have the address and the private key. This is the address. I'm just copying this right now. Account. So this is my address. And then my private key, I can share this with you because I don't have money here, and this is just a new account, and it's for testing, so it's fine. I can click in Show Private Key. I put my MetaMask password, hold to reveal private key, and then now we have my private key here. So with this private key, I can access to this address. And there are not two exact same private keys in blockchain or also two exact same addresses in the blockchain. So now, do you guys understand this accounts concept and also the MetaMask? No questions with this?
One question.
Yeah.
So when you create a wallet, is that considered a separate transaction that's stored in the blockchain? Or is it?
No. If we, okay, let me for example show you. I'm going to copy the address, and then I'm going to the Block Explorer, and then I paste here the address. Oh, it didn't paste. And then we can see that there is a empty account there. There is nothing there. But there is not like a creation thing. Only when we create the smart contracts, then that will be a transaction. Always when we write something in the blockchain, like when we send transactions, for example, if we create a smart contract, we need to send a transaction to write that smart contract in the blockchain. Oh yeah, that's mainnet. But that will be also that account can exist in okay, another thing. This account can exist in 100 different blockchains, even more in all the Ethereum virtual machine blockchains. So this account now exists in Ethereum mainnet, also in Sepolia. It can also exist in Avalanche, in Polygon, etc. But then depending on where I send funds, I will have funds. So for example, I can send funds in Sepolia testnet. Let me just show you for you to understand something here. There are a lot of different blockchains. Where's the account? Okay, so I will send 1 ETH to my account in the Sepolia network. Remember that Sepolia is the Ethereum mainnet testnet, so the testnet of Ethereum. And then if we refresh my account in Ethereum, it will still have 0 ETH because I haven't sent any ETH to that account. You can see here. But then if we go to the Block Explorer of Sepolia and we refresh, now we can see that I have 1 ETH. Do you guys understand this concept of different blockchains, different networks? Or any questions so far? Don't be shy. I'm really good at coming back and explain things in a different way if you don't understand that. Yeah? This has a transaction cost. Yeah, because I just sent, then let me show you. Good question. I sent that transaction from this Vault account because I have a lot of ETH here. But then if we go and check this account, oh, this is mainnet. We go and check this account in Sepolia testnet Block Explorer. We can see that 50 seconds ago, I transferred 1 ETH. And the transaction fee was this. So that cost, but to the Vault account and not to the CUEA account because that one just received. That one didn't send the funds. But yeah, it was here. And then as I mentioned before, you can see everything in the blockchain that I have been doing with this testnet account. And then if we check to view all transactions, you can see that my first transaction with this testnet account was 163 days ago, where I got these 500 testnet tokens. So yeah, that's basically the Block Explorer. Is really important because we can check like our balance. When we deploy a contract, we can see the contracts, etc. Yeah, I don't know if you have any question with this so far. Yeah.
When you create a wallet, can you actually delete it from the blockchain?
That's a good question. No, the wallet will be always there. But then if you forget your private key, the funds will be there forever, and no one will be able to move those funds from that wallet. That's why the private key is really important, because that will give you access to the funds of that address. Yeah.
So the hashes, does it store the information of every information like the person and the amount that it transacted?
Yeah. In every block, what is stored in every block is only the transactions that are done in that block, and then that update that in that block. But the other things that were in the past, that's not really like stored in the new block. That's just in the other blocks. But then if someone from 10 years ago didn't move the account, and now they just moved the account now, so now the information will be updated in this block. And let me just finish with this. And then if you want to be a validator, a full node, then you need to store all the blocks since 10 years ago. And then I don't remember how heavy is that. How heavy is the Ethereum blockchain? I don't know, 2 terabytes or something. Data size. Okay, 1,000 gigabytes so far. So if you want to have a whole full node to store all the blockchain information, it will weigh, the size is 1,000 gigabytes. Yeah, tell me, other questions?
These cryptos, they are used when you want to be anonymous. So that's why I've asked that question.
I didn't get the question.
The question was, is it really anonymous if
Oh.
information?
Oh, okay, that's a good question. Now you know my address. So if you know my address, you know that the money that I have here is Santiago. But if I never tell you that this was my address, how do you know that this is my address? And actually, that's the real word is not anonymous, but it's pseudonymous, something like this. Yeah, that's like the real word of this wallet, is pseudonymous. And not really anonymous, because yeah, it's not really secret. You can see everything, but then you don't really know who is that person. But yeah, if you never say what is your address, then we will never know what is your balance or what have you done. But that's also the beauty of blockchain, that everything is public. And then if, let's say, the government is using blockchain, we'll be able to see where they are spending the money, because everything will be public there, right? So that's like a really good use case for governments to have all the data, everything public and transparent. It will be really, really nice that everyone can come here. Yeah, everyone can come here to the Block Explorer and can see, okay, they just spent $100 in a lunch today. That would be really, really good to see, right? How they spend the money. So that's why not all the use cases are for blockchain. It's just when you really want to have this transparency and public and decentralized things, it will be a really good use case. Otherwise, it's just better to have a normal Web2 application. Any other questions? Yeah.
It's secure. Basically, what's it doing is encrypting your information. Like the input you're putting there, encrypting hash.
So let me tell you something here. Yeah.
So basically, what you're doing, the input, it's being encrypted and being output as a code.
Okay, almost. First thing is encryption is not the same as hashing. For encryption, you will always need, let's see, we have like an image here. For encryption, we will always need a private key or something that we can use to decrypt later. So, for example, we have this key, we have a text here. Then we use this private key or any type of key, and then we can encrypt the information. And then to decrypt the information, we will always need that key to kind of return the value to the normal state, right? But the difference with hashing is that you cannot really return the value to the normal state. Like by having this output, you cannot check these transactions. That's like a difference between hashing and encryption. But then with the private key, you are able to access to the text again. Also something else that's a little bit more advanced, but also for you guys to understand, what is really stored in the blockchain is just one hash. Let me just show you here. Because you can wonder why we have only here one hash. And to come up with this hash, what happened is that there is something called Merkle tree. So let's say that we have this hash here. This is the, oh, it's not copying. This is the hash of this block, right? But then what happened is that we have here one transaction, here one transaction, here one transaction. Let me just do this quick. And then we are just having something like this. And the same will be, it will be the same here in also this side. And then every little square that you see here is a transaction hash. Because we can check that every transaction, for example, if we come here, we are going to send transactions today. But if we check these latest transactions, the transaction will also have a transaction hash. So that's why hashing is like the most important thing in blockchain, I would say, because it's used for everything. So in this transaction, this wallet, this address interacted with this address. This was, in this case, was a smart contract, and they call the function confirm inside this smart contract. So let's say that that's this transaction here. Then we have another transaction here, and now they will hash these two, and then we are going to get this hash of this transaction here. And now when we hash these two, we are going to get, when we hash these two, we are going to get this parent hash. So basically what's happening in the blockchain is that all the transactions are being stored in this Merkle tree, like 2 and then 2 and so on until we get only 1. And then this will be the hash header of the block. Yeah, this is something really complex. I don't even know this 100%. And we don't even need to know this, only if you really want to understand all the infrastructure and all the protocol of the blockchain itself, you can dive into Merkle trees. But at the end of the day, I'm more like a dApp developer, and I just want to build on top of the blockchain without caring about. I already know how this works in a high level, but I don't want to really deep into how this works. But yeah, that's called Merkle tree, if you want to understand a little bit more about that too. Any other questions? Yeah. Okay, so if I send 1 ETH to Moses, what you will see here is my address and his address, because my address is sending 1 ETH to his address. But the private key is only used for me internally to sign this transaction. And then once I sign a transaction, this transaction will go to the blockchain nodes. It's called like a mempool. And then the nodes will verify that that was signed by me. If you have a signature, let me put this here too. This is an important concept. That's why I like to improvise things, because you will just learn things that you want to learn and not things that I come here to teach. Okay, if we have a signature is basically you take a transaction and a private key. There is even a function, I can show you that with Web3.js as well, where you have a transaction, then you put your private key, and then you will have this signature. Let me just put it here. And then the magic of the signature is that if I send you my signature, you will be able to see what is my address, but you cannot see what is my private key. And then just by knowing what is my address, you will see, okay, so this is a real transaction that I send 1 ETH to Moses. But then at the end of the day, if we go to the Block Explorer, you can only see from. So let's say this is me, and this is my address, this one here. And then I send 1 ETH to this address that is Moses. And then in this case, the value should be 1 ETH if I send 1 ETH to him. Actually, if we check this transaction that I sent from the vault, that's what you can see here. Remember that 10 minutes ago, I make a transfer. So if we come to see the transaction, we have the transaction hash, the time. This is the address of this vault. And then if we check the other account, this one is this address as well. So as you can see here, we see both addresses, and then the value that was 1 ETH that I sent. And then here you can see that this address, the only move that has done the only transaction is that it received 1 ETH 11 minutes ago. Yeah? Any other questions with this? Okay, so I think what we can do now is maybe code a smart contract. Now let's have some fun here. Okay, so something that I always use for getting started, and also I learned in this way too, is using Remix. Remix is a really good tool that allows you to write, deploy, and test smart contracts. So you can just go to remix.ethereum.org. Let me put it here in this Remix IDE. Okay, and then here we are going to create a smart contract. Okay, maybe I will ask you guys, which smart contract do you want to create? Maybe this will be to improvise today, but we have different options. One can be like a ERC20 token. One can be maybe a voting contract. Another one can be, okay, like a emit certifications contract. If I want to emit like a diploma university, let's say diploma university. Oh yeah, if someone else has another idea, we can also do that. How are you doing? No, nice to see you. So okay, let's count. Who wants to do a ERC20 token? Raise your hand if you want to do that one. 2, 3, 4. Okay, 4. Yeah. Want to do a voting contract? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and who want to do a mid-diploma university contract? 1, 2. Okay, 2. Okay, so then let's do a voting contract. This will be an interesting thing to do. Who has never done any Solidity before? 1, 2, 3. Okay. Okay, so maybe before we do this voting, maybe let's do a simple contract that is just like a message contract. So we don't start with heavy code. So in this message contract, what we are going to do is just a contract that will allow us to write a message and then a function that will allow us to retrieve the message. So only 2 functions and 1 state variable that will be a string with the message that we are going to update. So the smart contracts will always have a license. I always put, let me put a bit of zoom. Yeah, so the license, I always use MIT. So we need to type spdx-license-identifier, and then the license that you want to put here. When you go to Remix, you will get the default workspace, and then you will see these 3 different contracts, and then you can see all the, like some examples. So as you can see here, we have the license, then here we have the Solidity compiler version, then here we have the contract object. But then I'm starting from scratch, so I have this blank here, and then I have the message contract here. So yeah, first thing, the license. The second thing, the Solidity compiler version. So I will use 0.8.0. The latest one is like a 0.8.27, something like that. Then we need to create the contract object. So let's call it message. Who has a question so far with this? I will stop a lot, so I make sure that we are all following, and don't be shy to ask questions. There are no stupid questions, so maybe if you are shy, someone else will have the same question. Yeah. Okay. So we go to remix.ethereum.org, right? And then when you get here, what you will see is something called workspace here. But then you will be in the default workspace. The default workspace will have all these different folders. You don't need to care about that. But then in the contracts, they already have like 3 predefined contracts. You will see a storage, owner, and ballot. And they have these contracts there by default. But then what I did, it was just to create a new workspace, create a new workspace. Actually, I will create a new workspace now. How can I create one? Oh. Okay, I don't even know how to create one now. But yeah, let's just use this blank. So the only thing that you need to do is to create a new file. So you can just click here in create a new file. And then when you click there, you can create my contract.sol. You just put a name file, then .sol because this is Solidity. Let me take the zoom. Oh. And okay. Okay, and then we are here in my contract.sol, right? We are now in the same screen. So just create a new file, put any name, .sol, and then we can start here. Yeah. Remember, first thing, spdx-license-identifier, and then you put the license that you want. I don't know anything about license, to be honest, so I just use the MIT. Pragma, Solidity, then the compiler version that you want to use. For learning purposes, I always just put the 0.8.0. and then the contract object. Okay, is that clear now? Yeah, perfect. Any other questions so far? Okay, so what we are going to do with this contract is to have these two functions, write the message, then get the message. So the structure of a smart contract is normally in the top we will have the state variables. This is just the data that we are going to store in the contract. Then we are going to have writing functions and reading functions. There can be other things, but I don't want you to be overwhelmed today. But you can also have events and different types of variables here. But this is really good enough to get us started today. So for the yeah, perfect. So yeah, we have the license, we have the Solidity compiler, the contract object that I called message, then we just open the curly braces, and then I just added some comments there. So the first state variable, and the only one that we are going to have, will be a string. That is the message that we are going to store in the blockchain. So this is basically how we can add a state variable here. Then there are also different types like the U into56, or also addresses, address, etc. But I will add one more once we get the first basic smart contract. So who can tell me what do you think is the difference between writing functions and reading functions? One volunteer before I choose randomly. No volunteers. Okay, you, the girl there. Yeah. What do you think is the difference? Reading functions and writing functions inside the smart contract. Fetch data. Perfect. You are 100% right. So in writing functions, we are going to write a functions to change the message, to update the message, right? That's why it's called writing functions, because we are going to update the message. And then in reading functions, the only thing that we are going to do is to fetch the message for us to kind of retrieve what is the latest message. So to write reading functions, we always need to type the keyword function, then the name of the function. We can call it get message. In this case, this function will not accept any parameters. And then reading functions will always have the keywords view returns. View returns. And then in the parentheses, we need to specify what is the variable that is returning. In this case, will be a string. So we need to type here view returns, and then a string, and then we open the curly braces. And then there is something else called function visibility that by default, I'm going to show you this in a few seconds. What is the difference between external and internal? But basically, external is that anyone will be able to interact with this function from outside the smart contract. And internal, you can only use this function inside the smart contract. So I'm going to show you the difference in a few seconds. But let's use only internal for today. When we use strings in Solidity, we always need to specify that they are in memory. So we just need to always put the keyword memory next to strings. Who has any questions so far with this? Yeah.
What is the license? What is it like errored out?
Oh, it's not really an error. I don't know why. I mean, the most important is that it's compiling, but I don't know what is the error.
What happens if you don't specify the license?
Oh, I think you will not be able to. Okay, I think it will compile. It will compile? Oh, interesting. Yeah, I don't know. I learned always put in a license, so I always put the license. And if you check all the contracts, they always have a license. But that's a, yeah. I never saw a contract without a license. That's a good point. Yeah, I always use the MIT. Any other questions so far? Okay. So what we are going to do inside this function is just basically return this message. So I just put return message. As simple as that. This is returning a string memory, and the string that is returning is the message that is here in line number 7. This is clear so far? Perfect. Who is not familiar with the term constructor? Who don't know what is a constructor? Everyone knows what is a constructor. Perfect. When you have classes in JavaScript or in any type of programming languages, the constructor is the function that kind of gets called only when you, in this case, deploy the contract. So it will be called only one time in the beginning. So the constructor is a function that will only be called, is the first function that will be called and will not be called after. Only in the deployment, when you deploy the contract to the blockchain, you are calling this constructor and the constructor kind of dies. You cannot call it anywhere. So in this case, what I'm going to do in the constructor, when we deploy the contract, I want to initialize this message with a message. So we just need to type the message equal, and then the string that I want to hard code. This is the message from the constructor. Or we can also just send a string here as a parameter, and then put here the message like that. But I will just hard code the message, so it will be just easier to understand. So what happened is that when we deploy this contract, we are going to hard code this message. We are going to update the message with this string. And then this constructor will not be able to be called like after we deploy the contract. So I want to test this right now. And to test the smart contracts, first we need to check that it compiles successfully. So we will see this green check here. What I always do is that I check this auto-compile. So every time that I type something, it will auto-compile right away. And then I will come to deploy and run transactions. And then we can deploy the smart contract in a remixed virtual machine. This virtual machine is just like a testnet environment for you to test your smart contract. So when you come here, you will see in the environment, remixed virtual machine. And then you will have all these accounts. Remember that we have the addresses here with 100 ether. This ether is for testing inside the smart contract. So if we select the last one, for example, it has 100 ether. But then when we deploy the contract, we are going to spend some ether deploying the contract. So I can just scroll down. I can select the contract. In this case, this is message contract that we have here. And then I can click in deploy. And then when I deploy, the contract is already deployed here. If you scroll down, we'll have deployed contracts. And then we can see that our contract has only one function that is called getMessage. So if I click in getMessage, we will see that it's returning, this is the message from the constructor that we already set when we were deploying the contract. Remember that when we click in deploy, the constructor is kind of running when we deploy the smart contract. Any questions so far with this? If you are lost, let me know and I can repeat anything. We only have one function that is getMessage, which is returning this state variable. And we are just in the constructor updating the message with this string. So is this clear so far? Okay. So now we can write the function to update the message. Because otherwise, this contract, once we deploy this in the blockchain, like we will never be able to update the message if we don't write a function that allows us to update the message. So that's why we need to have the writing functions. So we need to type function. Let's call it update message. And then this will receive as a parameter a string. Remember that always we need to put a string memory. And then let's put new message. And then here the keyword external as well. And then the only line of code that we need to put inside this function will be message. That is our state variable of line number 7 equal to this new message that we are sending as a parameter here. And then this function will update our message state variable. Any question with this function or with anything so far? Okay, I will give you a few seconds for you to write that. You see that some of you are writing. That's great. Okay, so now let's test this in the remix. So I'm going again to deploy the contract. So I delete this contract that I deploy before. I deploy, I scroll down, and now you can see that our contract has two functions, get message and update message. If we click in get message, we are getting the message that we updated in the constructor. This is the message from the constructor. And then to update the message, we can just put a string here. This is the second message. And then if I click in update message, I will send a transaction. And this transaction is updating the state in the blockchain. That is basically updating this state variable message. So I will click here. And then if I click in get message again, we will see that this is the second message. Do you guys get this so far? Any question with the functions? And also you can see that the balance of this account now is 99.9999 instead of 100 because we sent some transactions already and we deployed the contract too. So any questions with this so far? No? Are you completely lost or you understand everything? Good? Okay. Okay, that's perfect. So I think, okay, then what we can do is we were testing this in this Remix virtual machine, right? But then let's have more fun and then let's put this in the Sepolia testnet. So if you want to deploy this in the Sepolia testnet, instead of putting the environment Remix virtual machine, you only need to change to injected provider MetaMask. Then this will connect to your account here. In this case, this connected, let me change my account. Yeah, so when you don't have any account connected and you click in MetaMask for the first time, MetaMask will pop up and will ask you to connect any of the accounts that you have. So in this case, I will use my CUEA account, confirm. And now you can see that it's connected to my account that has 1 Ether and also to the network Sepolia. So now if I click in deploy, this will not deploy in the Remix virtual machine, but this will deploy in the Sepolia network. So if I click in deploy, MetaMask will pop up. And then it will ask me to do this contract deployment. This is the cost, the transaction fee, 0.009, etc. I just confirm. And then I can come, oh yeah, this is actually my account. Remember that this account, I just created this like 12 minutes ago, and I just received 1 ETH. So if I refresh this, we should have the contract creation, the contract deployment that we just deployed in a few seconds. Okay, you can see that now my balance decreases because we just deployed the contract. And that should update here in a few seconds, and we will see the contract creation. Yeah, so contract creations, 31 seconds ago, we have a contract creation. And then if we click in contract creation, this is the address of the contract. So let me just put it here in the README. And then this is address of my account, contract. You can see that the addresses are the same length, but they are different. Contract address, and then private key of my account. Just not this here. Okay, any question with this contract deployment so far? We just came here, deploy, and then we changed the Remix virtual environment, virtual machine to injected provider, disconnected to MetaMask, and then we just click in deploy. If you want to get testnet tokens, you can come to, let's say, Google Sepolia faucet. Then you will have this Ethereum Sepolia faucet from Google Cloud. And you just put your wallet address here. You click in receive. And then they will send you some Sepolia tokens for you to be able to interact with the testnet. Because you need funds to interact with to deploy the contracts, or also to update the message, you will need funds. So any questions so far? Yeah?
Let's say we change, make changes to our smart contract, then deploy it. Maybe will the contract address change?
Yeah. Okay, good question. So we have this smart contract here, right? We have this state variable message, this function update message, and this function get message. So the question is, if we update something in this contract and we deploy again, if the address will change. Yeah, because we will need to redeploy a new contract, and that will be a new address. So every time that we update something, that will be a new contract.
Can we have a way maybe of addressing data of a smart contract and we don't have to change that?
Okay, that's an advanced question, but yes. So what happened with the smart contracts? That when we deploy this contract that I deploy here, this contract will be here forever. Like in 10 years, you can come to this contract, and the contract will be there with the same code, the same transactions. But then let's say that in 5 years, I want to update something here. Let's say that I want to put a new state variable that is called owner, and this owner will be my address. But then for me to be able to, let's say I want to do this, owner equal, well, yeah, owner equal to this address. So if I do this simple change, then that will be just a different address, a different contract. So when you create an application and you make any change, now you need to change the contract address to interact with the new contract. That's, I will say, the beauty of blockchain, that if we are interacting with a game or a protocol that has a smart contract, we know that that smart contract will be there forever. And if that contract is audited and they don't have any mistakes, so the contract is secure, right? But what happens if I want to update something in that contract because we make a mistake? You will need to redeploy a new contract and now tell your users, don't use that contract, use this contract. But then there is something called proxies that's a bit more complex, but that is useful too, that will allow you to update the contracts. So what happened is that we will have two contracts. Let me show you here. I forget specifically what is the name of each contract, but then let's call this one, I don't remember. Let's call it router contract. It has a specific name. Let's call it like this, router contract. And this is the implementation. So this implementation one is basically the first smart contract of my game. Let's say that I created a game and all the logic of the game is here. And then we have, let's say, the dApp. This is the dApp, like the front end is here. And the front end is connected to this router contract. And then when you interact with the router contract will say, okay, the implementation of this game is in this contract, right? But then in 5 years, I want to add a new feature to the game, so I will have a new implementation too. Let's put this big. So now I have a new implementation too. And then what will happen is that we will ask our router contract to interact with implementation 2 and then forget about this one. And then this is called proxy. There are different patterns of proxies in blockchain. And this is what you need to use if you want to have upgradable smart contracts in the blockchain. But then that's tricky, because then if I have a DeFi that is using this, and then I want to implement a new feature that will drain all your wallets and will send the money to me, then I can implement that here, right? And now here my dApp was secure, but then here I implemented a malicious thing. So that's the tricky part of the upgrading smart contracts or not upgrading. That really depends on what you want to do. But yeah, then this is called proxies. That answer the question? Perfect. Any other questions? Yeah.
So the reduction of the amount.
The what, sorry?
The reduction of the amount that you had while deploying. That's what is called gas.
Yeah. So if we check here, in the contract creation transaction, because that was a transaction when we deploy the contract, that has a gas fee that is here, transaction fee, and then the price of me deploying that contract was this 0.00911, etc. And yeah, I pay to the blockchain this fee to deploy the contract. And now if we interact with the contract to update the message, we will also need to pay transaction fees as well. We are going to do that now, like after I verify the contract. Yeah.
So, on the same note,
The proxies?
he was asking, just this idea of creating NFTs, right? So, an NFT basically carries metadata of
Yeah.
an individual NFT. So, for my use case, I use it in my game. So, but I want to make it more dynamic in such a way that as the player advances using this NFT in the game,
They advance the level or something.
yes, maybe reaches a certain level, and I want to change the metadata of the NFT every time the NFT advances. So, but I don't want to change the NFT.
Address, yeah. You don't want to deploy a new contract. Yeah. So that's a good question. In that case, you know what I will do? Let's say that we have an NFT here. So I will just create nft.sol. And then I will just do this. And then we can have a state variable that can be levels. So levels will start in level 0, right? But then what you will need to have is a function that upgrades, let's say, advanced level. And then every time that the user does whatever in the game, you will call this function, and then you will just do this, and then you will advance. Okay, we can have something called mappings here. Okay, who know what is mapping? Mapping is really important, so let me explain that too. Who don't know what is a mapping? Perfect. So mappings are key value pairs. Maybe you know it in that way. So we'll have, let's say, addresses connected to uint256. In that case, the address can be the player, and the uint256 will be the level, because we have level 1, level 2, level 3.
So, we can add more features.
Yeah, that's what I'm going to do now.
So, I also want NFT to be traded among players. So, maybe we can add the owner, maybe so that we can transfer.
Okay, he's getting excited with the contract. Let's do that. So we will have owner of this contract, and then we will have the mapping. This is the most important state variable. That will be an address. That will be the address of the player. With a uint256, that will be the level of the player. So let's say, to make it easier to understand, in the constructor when we deploy, we will set that the owner of this contract is called Santiago. Oh, it's an address, but yeah, let's put a string to make it easier. So the owner of this contract is Santiago, right? For now. Then we will need to have, let me just put these functions, and then we implement them. One function to change owner. One function to advance level. What else we can add here? Yeah, for now we can add a lot of more functions, but I think these two will be good enough, right? So then what happened is that when we advance level, we need to call this mapping of level. Let me actually remove this one. We don't need this one anymore. So we'll have this mapping of levels. Let's call it player levels. So then what happened is that we are going to call, let me put it in this way. Let's say that we have 3 players. This is one player that ends in E. This is another player that ends in A. And this is another player that ends in X. I mean, X cannot be a digit here as character. Let's say, which character? C. Okay, so we have these 3 players. By default, in the mapping, all the players will be level 0. Because 0 is the default uint, right? So if we consult, like, let's say, what is the level of this address, it will return a 0. Maybe let's implement that. That will be easier. So we have these 2 writing functions, and then we are going to have a reading function. function to check level of player. Then this check level of player will receive an address. That will be the player address that we want to check. Is external view returns, and it will return a uint256 that is the level of that player. So for us to check that mapping, because we are going to send one address and we want to get this level of the player, we need to call this player levels mapping. So we just return player levels, then we open these square brackets, and then we just send the address of the player here, and that will return the level. So if we check right now, we can come here, deploy in the Remix virtual machine. I click in deploy, and now we have our NFT here. And we have advanced level, change owner, and check level of a player. These ones are not doing anything because they are empty. But then if we check the level of a player, and then we put this one, it will be 0. Because by default, all of them will be 0, right? So now let's implement the advanced level. So this will also receive an address of the player that we want to advance the level. And then we will need to access the mapping again, player levels, pointing to this address of the player. And then we can upgrade this to +1, because we are advancing this player by 1 level, right? Perfect. And then the change owner function, we can implement that too right now. But then if we want to call, we want to call this one, we want to say that only the owner can change the owner, right? Because we don't want that anyone can come here and change the owner. So we can put something that is called required. This is getting more advanced now. This is a little bit, if you are lost, everything will be recorded, so you will be able to follow that. Then we will have this require that would say the person that call this function needs to be the owner. The owner is Santiago. But then let's put, we'll need to have actually an address owner. That would be better. And then the owner needs to be, let's say, this address. The address here. We are going to hard code the owner, and we are going to test that. Owner is equal to this address. So what I did so far, remember we have these two state variables, owner and player levels. In the constructor, I'm hard coding the owner to the first account that we have here. So only this account will be able to change the owner, because there is a, I always forget the name of that, the solidity global variable. There is a global variable called message.sender, and this message.sender is basically checking the address that is calling this function. So we need to require that the message.sender, the caller of this function, is equal to the owner. If this is false, then the function will not run. Will just kind of cancel the transaction, will not succeed, and we can return a string here that says you are not the owner. So this require is just to double check that the only person that can change the owner is the owner. That's why we have message.sender equal to the owner. And then after that, we can say the new owner to new owner here to a new owner. So I can go through this contract again. Do you have any questions with this one? Yeah? Oh, that always needs to be there by default to know what is the compiler version of this contract. But that always needs to be there, the license and the Solidity version of this contract, because there are different versions of Solidity. For example, below Solidity 0.4, there was an error with the negative numbers. So if you have, let's say, you want to decrease the level of a player and it's 0, and if you call that 0 and you put a -1, that will have an error, and the number will be like millions of numbers. That was like an error with the compiler. But then now we are using 0.8.0, and if you have that error of when you put 0 and then you reduce -1, it will just return an error, but will not update with a huge number there. So that's just to know what is the version of Solidity that you are using in this contract. Any other questions? We're going to test the contract here. Yeah, this was a little bit deep, this contract. So we have the constructor that is setting the owner with this first address that we have here. Then we have three functions. One to advance the level of a player by one to change the owner of the contract, and one to check the level of a player. I will even say that all of them should be required, that only the owner can call the functions, but let's leave it like that for now. Then if we click in deploy, we will have these functions. Actually, let's create one to see the owner. We want to see who is the owner. So we can call it get owner, external view returns. Then this will return the address of the owner, return owner. So this is also a reading function that will just return the owner state variable. So we just deploy again. Okay, so we can see that get owner, get owner is returning this. And then if we check the level of the owner here, for example, is 0. Yeah. And then we want to advance the level of the owner. So I just paste here the address, advanced level, and then if we check again the level of the owner, we get a 1. Then we can just click again here twice. Just click several times. Every time that I'm clicking here, I'm sending a transaction and I'm spending Ether. So I'm doing a lot of clicks here. Then if I click in check level of the owner, now we see that my level now is 20 because I click 20 times and I send 20 transactions. And yeah, this is basically can be like an NFT for gaming, and now you can set a new owner and you can do whatever you want. Just being more advanced, you can add more things, but I think we can just leave it like that. The most important is that you understand these mappings, because then this is saying that the level of the owner right now is 20, but then the level of the rest of the addresses that can exist are 0. And then we can just keep updating this mapping by updating the level of the different addresses, the different players. Any questions so far with this contract? Yeah, anyway, because this is Remix virtual machine, it's not really accurate, but then if we deploy this in the, maybe let's interact with the other contract, and then we can see the gas fees. That will be better. Yeah. Okay, what determines the amount of gas fees? That depends on the complexity of the function that you have here. So let's say that here in this line 24, we are only increasing this uint by 1. But let's say that here we are doing a for loop of 1,000 loops. Then that will be really expensive. So that's why when you are writing Solidity, you need to be really efficient with gas fees. And I wouldn't really even advise to have arrays in Solidity and have mappings instead, because with the mappings you are not to update something or to check something. You just click, like you just send the address and directly it will retrieve, because this is the key value pair, it will retrieve the value of this. So mappings are the best, I would say are the best, how is that called, variable? I think it's called variable of Solidity, because it's the most efficient one if you want to update things like this. But yeah, what determines the fee of a transaction is the complexity of the function that you are having in the contract. Yeah.
After that summary that the gas fees can also be, let's say for example, there are a lot of people making transactions.
Okay.
Also,
Okay, that's true. So then, yeah, so then there are two variables. So the first thing, let's say that calling this transaction will cost 20,000 gas, right? So that's always the gas price of calling this transaction, right? Now another thing is the price of this gas, because this is gas units, but then the other thing is the gas price of the network. So right now you can also check the gas price of Ethereum, and this gas price changes depending on how many transactions are being sent in the blockchain at that time. So we know that the gas units required to call this advanced level is 20,000, but now we will need to see how much that costs. Let's say something really quick in dollars. So let's say that right now the gas price is $1. So every unit it costs $1. So we know, let me just change this. So for calling the advanced level function, it will cost us, for an example, $20,000. Oh, I don't know what happened. Oh yeah, perfect, thank you. So for calling this advanced level, it's calling 20,000 units times $1, so equal to $20,000, right? But then let's say that tomorrow there are a lot of transactions and now the gas price is $2. So now the cost of this will be $40,000, right? So there are these two different things of gas price and then the units of gas that requires to call that function. So those two things will determine the total price of the transaction fee.
The more active an ecosystem is,
The more expensive.
the more expensive it gets. So anytime asset prices go up, gas fees goes up.
So there is something else that is called the blockchain trilemma. Wow, this is the beauty of improvising. I hope you don't get really lost with all this information. So the blockchain trilemma that we have is that a blockchain has three issues: that it cannot be scalable, secure, and decentralized at the same time, right? So that's why we have something called layer 2s. And then those layer 2s are coming to contribute to Ethereum to help to solve this problem of the trilemma. So what are the layer 2s? Actually, layers CK Sync is one of the layer 2s. But then let me do something here. Okay, you are learning a lot today. We have Ethereum mainnet here. This is the blockchain, right? Ethereum mainnet is a layer 1. And then we have, let's say, CK Sync, that is a layer 2 here. And then what happened is that, let's say that CK Sync uses a different method of validating the transactions. So CK Sync is faster. But let's say that CK Sync is not as secure as Ethereum. So then what happened with the layer 2s is that they use the security of Ethereum to store all the data that happened in CK Sync. So CK Sync, let's say that they will have 1 million of transactions per second. But Ethereum can only have, let's say, 10 transactions per second, right? So in 1 second, CK Sync will validate 1 million transactions, and then they will have this hash that we have in the beginning, the hash in the block. And then that hash will be stored in the Ethereum mainnet. And then that's how they are kind of having this relationship of layer 2s and layer 1s to solve the blockchain trilemma, because CK Sync is having different solutions maybe for security, decentralization, and scalability, but they are still using Ethereum under the hood, and everything that is happening in CK Sync is being registered in Ethereum. But all these 1 million transactions are just being stored in one transaction here, not 1 million transactions in Ethereum, because that will be too expensive. So that's why the layer 2s are coming into the game, and there are a lot of layer 2s right now. So you will have also, let's say, Polygon CKEVM doing their magic here, whatever, and then they submit the transactions in Ethereum as well. But it will be only one transaction. And then if Polygon is having 2 million of transactions, now in 1 second, we basically store 1 million of transactions here plus 2 million of transactions here. So we stored 3 million of transactions in Ethereum, but only in one transaction. So that's the complexity of layer 2s, layer 1s, and that's why Ethereum is not really scalable, because the more that we use Ethereum, the more expensive it will be. But then that's why the layer 2s came into the game to solve those issues.
So then in this case, when it comes to how the codes are being compiled, does it mean that you'll have to learn maybe for CK Sync how to compile the codes, and you have to learn how
Okay, good question too. So a blockchain has different layers. Something that is called the settlement layer, the execution layer, but the most important layer, and the one that I know the most, is the application layer. And the application layer is in the one that you build the smart contracts, that you build the applications. And all of these blockchains, layer 1s and layer 2s, they share the same application layer. So this contract that I have here, the NFT that we just have here, can be deployed in Ethereum, can be deployed in CK Sync, can be deployed in Polygon, it will be the same contract, the same Solidity language for all the Ethereum virtual machine networks. That's called EVM.
Okay, great. So in this case, let's say let's just use the
NFT, yeah.
does it mean, let's say, the more people are interacting with maybe the NFTs you have created, that means more users, right? So
Yeah.
if you have more users, um, maybe in the app that you built, how does that affect the gas fees of it? Does it mean that the more users you have, you pay a higher gas fee maybe because you're using more resources
In the blockchain or in the contract?
in the contract?
Like the contract always will here, this will always cost 20,000. Yeah, it will always be 20,000.
Okay.
Then the issue will be if we have 100 people calling advanced level at the same time, only the one that pays higher gas fees will be executed first. Because then the nodes, there is something called, okay, another term here. We have something called the validators. And these validators or the miners as well in Bitcoin are called miners, are the ones that are getting the transactions and are saying, okay, I will validate this transaction, I will validate this transaction. And I will validate the transaction that is paying higher gas fees. So if you want to advance level faster and you pay a little bit of gas fees than this user, so I will get your transaction first and I will advance your level first.
Oh, so your gas fees determines your priorities
Yeah,
with the nodes.
yeah, exactly. The faster, the higher the gas fees, the faster your transaction will go through. But the cost of calling this function will be always the same. Yeah, perfect. Yeah.
Why do you have to use why do you have to build on Ethereum then? So for example, currently I'm learning a layer 2 chain called Engine. It's for game developers, so it's cheaper and it's faster. So could you advise me to build solely on Engine and or should I also
What do you use to build on Engine? Solidity as well?
yes, but it's more simpler. They handle most of that work for you, so you focus more on developing your game.
On the game instead of the instead of the complexity of the logic of the contract.
Yes. But I would also like to learn Solidity so that I can add some conspec, some more advanced mechanics of the game. So that's why I'm trying to learn Solidity also. So,
I think learning Solidity is a really good thing because it will allow you to know how to build smart contracts for any EVM network and even other networks that are not layer 1s or layer 2s. Because let me tell you something else. All the networks that we have here, all these layer 2s, like these layer 2s and this layer 1 that is Ethereum, at the end of the day, this is one whole ecosystem. This is one ecosystem, right? Then we also have other blockchains like Solana. This is something different. Solana is a different blockchain, different thing. But now there are even some networks in Solana, some blockchains that are putting EVM in the application layer. So you can build smart contracts in Solana using Solidity, but then you will use all the other capabilities of the Solana network. Like maybe Solana is faster, will execute 10 million of transactions per second, whatever, but then you still build your applications in Solidity. So I see that a lot of blockchains are migrating to Solidity. So you can build applications using Solidity, but then using another, let's say, backend of the blockchain to be faster or more secure or more scalable.
more scalability and fastness also.
Yeah, yeah. You just learn Solidity, and then you can use different blockchains.
Okay, so there's also started. We have an engine called Dojo. Yeah,
Okay.
it's also for building applications.
Okay. Starnet Dojo. No idea.
So we put for the building
So
but the rest are different languages, kind of. So you have to learn.
Oh yeah. So you don't learn Solidity. You learn Cairo. That's why I prefer to learn Solidity, and then you can deal with all these things. But then if you learn Cairo, you can only do smart contracts in Starnet and maybe a few more, I guess. And that's the issue. That depends on the programming language that you learn, you will be able to have contracts for some specific networks. And Solidity is I will say, the most kind of adopted so far, so it's better.
Yes, I also tried Solana. Yes, as you said, it's faster.
It's faster, yeah.
Yes, but I don't think it's more secure than Ethereum.
So then layer 2s are the answer to that question.
Yes.
Yeah.
So
There is even one that is called B3. I don't know if that's already in mainnet. That is also kind of for gaming or something. We at Chainsep we are working with them too. I don't know exactly because I'm not in Chainsep. We have a gaming like a department as well, and I don't really know what that is, but it's like a blockchain for games. You can explore a little bit about B3 as well. Yeah. Yeah. Yep. Oh, that's fine. Okay. Any other questions? Okay. Okay. We've done a lot here with this NFT. Yeah.
I think to get more clarity on the gas fee that we pay for the transaction, can we modify our functions further to like
To see the different.
to return to the one who's calling the function the amount that has been used for the transaction?
Oh, okay. So for example, to call here things. I don't know if we are able to call the gas inside a function. You mean here, for example, to return the gas?
Yeah.
I think we can call the gas price variable. Yeah. So let's see what is that one. I think it's better maybe to call the functions and show in the iter scan what is the price of that. Because yeah, here we need to check what is maybe it's called gas price. Oh, I don't know. I have no idea what will be that one.
Just wanted to know if we have now to go to the ether scan or
Yeah, we can do that. I think there is a global variable. Global variables. Okay, let's see here. Okay, so yeah, we have the tx.gas price, which is a uint. So if you want, what we can do is maybe create a new variable that is called transaction gas. And then when we do this, we can also update the transaction gas for tx gas price, things like that. Let's see. What's the name? Oh, gas price. Okay, so when we call the transaction, the advanced level, we are also updating the transaction gas, and then we can create a function to return the transaction gas. External view returns. Return transaction gas. Let's call it this. Okay, so then we just deploy the contract again. And then we see that right now the transaction gas is 0 because we haven't called the function. But then if we call an advanced level function, and then we advance the level of a new user, then we can see the transaction gas that was 2. So I guess 2 units was the transaction cost to update this one.
so that is two-way.
Yeah, I think 2 GWA. GWA is the gas. Yeah. Perfect. Okay, I think this is clear. Maybe let's interact with the contract that we deployed a few minutes ago. So when we deploy this contract, remember that this contract, let me go back. This contract, the only thing that is doing, I think we have it like this. This contract, the only thing that was doing was having a message, updating the message, and getting the message, right? So we can come here to the contract that we deployed 36 minutes ago. We come to contract, and we can verify and publish the contract. So this verify and publish is just to make our contract public, the code, so everyone can see what is the code inside that smart contract. Otherwise, you will only see addresses, but you will not see what is the code of the smart contract of that smart contract. So it's always really useful and recommended to verify your smart contract. So we'll just need to click in verify and publish, Solidity single file, the compiler version 0.8.0, the license MIT, continue. Then we copy paste here the code. I hope this is the code. Oh, then it's not. Okay, let's just deploy the contract again, because I think I changed the code and that was the issue. So I will just deploy the contract again to Sepolia. And maybe let's just put this first message. Deploy in Sepolia. And here we are going to see the transaction receipt. Yeah, view on iter scan. So it's indexing. Let's see. So we just deploy a new contract again. That is taking some time. Okay, now we deploy the contract to this address. This was the transaction fee for deploying that contract. Then we come to contract, verify and publish. I will copy paste the whole code here. Okay, so Solidity single file, Solidity compiler version, license, continue. This is the code. I just copy paste that, verify and publish. Okay, and then it's just verify our smart contract. So as you can see, we go to our contract in iter scan in the Block Explorer. We have this green check because our contract is verified, and then you can see the code here. You can see that submitted for verification on iter scan in 2024, 9/20. And then you can see the whole code here, contract message, constructor, update message function, and get message function. And then this contract will live here for forever until the blockchain ends. And then you can see that we have this read contract and write contract functions. If I click in read contract, we have the get message is the first message. And then if I want to write contract, we will need to connect our wallet because we want to update the message, right? So if I click in connect wallet, MetaMask will pop up. Okay, I already connected this wallet. And then I can just update the message for second message. I can write. Then this is the transaction fee for calling this function. And actually, I can put this faster. Look, if I put this in the gorilla mode, I can be aggressive, and it can take 15 seconds because I am paying for more gas fees. So maybe let's put it aggressive, confirm, and then it will be confirmed faster. Then here we can view our transaction. It's still pending. Hopefully it will take 15 seconds. Then we can come back to the read contract. Let's see if it's executed now. Okay, not yet. I need to be more aggressive. Yeah. Let me see if here is updated already. So if I come to read contract, oh, we are still having first message. So it hasn't updated yet. Wow, it's taking some time. Maybe let's try to write again. Third message. Oh yeah, connect. So something that can happen, this is called front running attack. I think the other one was already confirmed, but if I just front run this and I pay higher gas fees than my previous transaction, so this transaction will overwrite the previous one. And then the other one will not be executed, and this one will be executed faster. But yeah, I think the other one was already executed, I guess. How can I? Let's see. Anyway, I think this was, yeah, this was already succeed 23 seconds ago. So if we come to read contract, we will see the second message here, and then the third message will be updated soon. So now I have a question, guys. Now you know how to write the contracts here, to deploy the contract to Sepolia, how to verify the contract in the Block Explorer. The Block Explorer is the most important part of the blockchain, I will say, because you can see everything there. That's why you can see a lot of don't trust, verify, because in the Block Explorer, you can verify everything. You can verify that if I send you one ETH, you don't trust me, you go here and you verify that I send you one ETH. We have two options. Maybe if you want to learn something new, we can create a simple front end, a React app to interact with this Sepolia contract. Yeah, or we can just create a new contract. I don't know. Well, you choose what you want to do. Who want to create a new contract? And who wants to create a front end to interact with this contract? Okay, let's create a front end. Any questions before we start with the front end? Okay, so let's start with the front end. Yeah. What is the purpose of what, sorry? Oh, so the only purpose of verifying the contract is that the code will be public. Because if you go here, you can click in contract and you can see what is the code of this contract. So when you interact with this contract, you know what you are doing. Otherwise, you cannot really interact with contracts that you don't know what is the code. You don't know what is happening under the hood. So if we go, for example, to USDC token, which is one of the most important tokens in Ethereum, a stablecoin, we can see that the contract is verified. This is just a lot of contracts because they have a lot of different things, but at least you can see, okay, they are using proxy. Something important to know, they are using proxy, so they can upgrade this contract anytime they want. And then they have all these different code here that if you are an auditor, you can come here and you can verify the codes to see if there is nothing wrong here, a malicious code or something. So the purpose of verifying the contract is just transparency, to show the people, look, this is the contract that I deploy, and if you interact with this, this is the code of my contract. Yeah. Oh, a little bit louder, please. Let's deploy. So you want me to verify it again? Oh, I'm not calculating the gas. The gas. Okay, okay, perfect. So let's do something. I have this contract here, and now I just wanna. The only thing that I will change with the previous contract is that maybe I will change the name of this function. Instead of update message, it will be set message. So now we are going to deploy a new contract just because we changed the name of the function. So if I click in deploy, MetaMask will pop up to deploy the contract, and we can play with the gas just to execute this deployment faster. If we want to execute the deployment faster, so we can click in aggressive, confirm, and then let me go back to my account here. Okay, so this is the account that I created for today. I created this contract. I interacted with this contract too, and now a few seconds ago I deploy a new contract that is loading. Need to be more aggressive again. Yeah, it's here. Okay, it's still indexing. Okay, 27 seconds ago from my address, I deploy a new contract, right? And then let's verify that contract again. So I will just go to the contract. You can see that it's not verified. So we can come to contract, verify and publish. And the only things that you need to fill out here is the compiler type. This is a single file because it's only one file. If you have different contracts calling each other or whatever, inheriting from the other ones, it will be a multi-file. But yeah, in this case, it's Solidity single file. Compiler version 0.8.0 that we specify here. And then the license MIT that we also specify here. Then continue. The other thing that we need to put is enter the Solidity contract code. So I will just come here, I will copy everything, paste here, and then verify and publish. And now we can see that the contract is verified. And now you can see that the function is called setMessage. That is not called update message because we deploy a new contract and we verify a new contract. Does that answer your question? Perfect. Any other questions? Okay. Oh wait. So then, before I answer your question, I will create the React app just because it will take a few time. So npx create React app. Let's call it Q. Okay. So I'm creating a React app. Yeah. Perfect. Question? Is sorry? No. Is Sepolia testnet is a blockchain. It's a blockchain itself. And then in that blockchain, you can do the same things that you can do in Ethereum. You can deploy contracts, you can send transactions, you can do a lot of things. But then in this case, the block explorer, that is Etherscan, we are deploying the contract, and we are using the block explorer Etherscan to verify the contract. So people can see what is the code of my contract. But the Sepolia itself is the blockchain. So let's say the blockchain can exist, but then if we don't have this indexer of Etherscan that is showing us what's happening in the Sepolia, then we will need to interact with the nodes ourselves to be able to see what's happening in every block. But then the Etherscan or the block explorer is just an interface of the blockchain that is showing us what's happening. If we come to the main homepage, it's showing us that this was the latest block 14 seconds ago. This is the other block 26 seconds ago. Or this was the latest transaction sent 14 seconds ago, etc. So this block explorer is just an interface of what's happening in the blockchain. Yeah, every blockchain has their own block explorer. This is sepolia.etherscan.io. And then if we go to etherscan.io, this is for Ethereum mainnet. Then if we go to Polygon Etherscan, then this will also have, oh yeah, it's called polygonscan.com. And then every blockchain will need to have their own block explorer, their own interface. And then you can see that in Polygon, this was the latest blocks, also the latest transactions here, etc. Perfect. Any other questions? Yeah.
I think smart contracts seem to be operating in the blockchain ecosystem. Now, how do they access off-chain data, let's say stock prices?
Okay, we have advanced questions now. This is a good one. So we cannot really access off-chain data because the blockchain don't really have access to what is the price of Apple, right? So what happened is that, let's say this is the blockchain. Yeah, this is the blockchain. And then we will need to have something that is called oracles. And then these oracles, what are they doing? Is that they have, let's say, oracle, oracle, and oracle. There are different oracles, right? This is maybe this one. This one is Chainlink. This one is Chronicle oracles, and this one is Supra oracles. So these are just different, let's say, companies, right? And these companies are oracles providers, and what they do is getting off-chain data of, let's say, the Apple stock into the blockchain because you want to create exchange, and then you want to allow people in the blockchain to buy the Apple stock, but you don't have the price of the Apple stock. So then you will need to call in your application one of these oracles, and the oracles, they have their own system. I don't really know what, like the infrastructure of Chainlink or Chronicle or Supra oracles. I just know that they will have a smart contract that you can call, and then they will retrieve the price of Apple, of the Apple stock, right? And then they are doing their magic off-chain. They have different computers, different nodes or whatever, but they provide a smart contract that you can call. Let me actually show you one. So Chainlink data feed is the oracle where we can access the price of different assets. So in this case, let's say Bitcoin, because in the Ethereum mainnet, we don't really have access to the price of Bitcoin. So we can use Chainlink oracles to get that. So if we come here, I'm just going to show you really quick. They have the oracles in these different networks. BTC, okay. So this is the smart contract of Chainlink that will give us the price of BTC. So if I come to contract, it's already verified. I come to read contract. The function, this is because I already know, but you will need to read the documentation to understand this, because these are all the different functions that this smart contract has. So where you can get the price of Bitcoin, right? The function is called latest answer. And this latest answer is retrieving the price of Bitcoin, which is 63,055, and then the rest are just decimals. So in this case, this is how we can access the price of Bitcoin inside the Ethereum mainnet or the other assets. Sorry?
So the oracle is basically the link between the blockchain and the.
Yeah. And then they also have something Chainlink, something that is called Chainlink functions that will allow you to create your own function to create any oracle that you want off chain. Like the I don't know, the result of a game, maybe you can connect that to an API using Chainlink functions, and now you can retrieve that in the blockchain as well. So that's, yeah, you will need oracles to retrieve data off chain into the blockchain. That was a good question too. Any other questions before we jump into React? Okay, perfect. So let's go back to our contract. So our contract is deployed here. This is the address of the contract. Let me put it here. Okay, let me just access this actually. Okay, so this is the React app. In the README, I'm going to have contract address. So this is the contract address that we are going to interact with, which is the one that I just deployed in Sepolia, right? Something that we always need when we want to interact with contracts is the ABI. The ABI will be here. This is just like an interface to tell JavaScript how we can interact with the contract, because JavaScript will not know the name of the functions of this contract. So with this ABI, we are telling the contract, we are telling JavaScript, like, look, the functions of these contracts are called update message and get message that is somewhere here. Yeah, it's somewhere there. Oh yeah, get message that is here. So these two functions are the functions that we can call in this smart contract. But then let's talk about Web3.js. Let me just run this first. npm run start. I will remove this. Oh, yeah. Okay, so we just have this React app. It's empty. And then I'm going to create some buttons to interact with all the functions that we have. In this case, our contract has only two functions, update message and get message. So update message. Update message and get message. Perfect. So far we just have these two buttons. And now we need to use Web3.js. So this Web3.js library, I'm actually a developer relations for Web3.js, and this is what I'm supposed to teach you today. Web3.js will be the link of the front end with the smart contracts. So if you know Web3.js and you know any front end skills, you will be able to interact with any smart contract, and that's what I'm going to teach you right now. So we need to install npm install web3. Then we will see that in the package.json, the Web3 library will be installed here. Wow, this has been the best internet that I have seen in all the workshops in Kenya. It's really good. Yeah, so we just installed the Web3 library. So there are a few steps that we need to do. I will put the comments here. So import Web3 library and ABI of the contract. Remember that we need the ABI of the contract to interact with the contract. Then we will need to initialize the Web3 library, then initialize the contract that we want to interact with. And then after that, I'm going to call the contract, which is kind of easier. It's easier. And then after that, we are going to interact with the contract to set the message. So this is the just get message. Okay, so far I just put these 4 comments, import the Web3 library. So to import the Web3 library, we just type import Web3. This is really important. This Web3 is with uppercase, and we have curly braces here from Web3. This Web3 is the Web3 that we just installed here when we run npm install Web3. And then the second thing is to import the ABI. So I'm just going to create here ABI.mjs. Then I'm going to Sepolia iterscan, and I will just copy the ABI here. So cons, ABI, paste. So I just pasted the ABI, export default ABI. Perfect. So basically, I just copy paste the ABI of the contract. I imported the Web3 model here, and then I imported the ABI as well. So far, I just imported these two things. Any questions so far? Yeah, I will stop if I'm going too fast. Any questions so far with this? Just imported the Web3 library, imported the ABI, and just added two buttons here in the front end. Yeah.
What's the .mjs?
Oh, good question. So there are two things in JavaScript. One is called ECMAScript and CommonJS. I don't really know what is the difference between them, but the main thing that is really annoying to me is the way that you import things. So when you use .js, you will need to import in this way, something like this. When you use .js, but I'm already learned and get used to the .mjs. So the .mjs is using import statements instead of the constant required. So that's the only difference of these two. That's more like a Node.js things. That I just always put .mjs. Any other questions? Okay, perfect. So first thing, import the Web3 library and the ABI. Remember that the ABI is in the block explorer. Then we always need to initialize the Web3 library. I think this is the most important line of code of our application, because how we initialize the Web3 library will determine the network of the application. So for example, if I initialize this new Web3 with an Ethereum endpoint, we are going to interact with Ethereum. Or if we initialize this with a Sepolia endpoint or Polygon endpoint, we are going to interact with different networks. Maybe let me do something so you are able to understand this in a better way. Let me just do a button. Chain ID. So every blockchain will have a chain ID. And then I'm just going to show you what is the chain ID that we are interacting with. Who is not used to user state? Who is not aware of this user state thing? I just like to explain every line of code that I put. So user state is just creating variables that we are going to render in the front end. So in this case, the variables that I want to render is the chain ID. So as you can see, I created this chain ID here that I'm going to render in this chain ID here. In this chain ID. So I just created a user state that is called chain ID, and this will be rendered in the front end that we can see here. Polygon endpoint. Yeah, so the chain ID by default is 0 that I put here, but then when I set chain ID, it will update for a new value that I'm going to update soon. So let me show you something here. There is something called RPC endpoints. The RPC endpoints is like a URL or a link to a node on a specific network. So if we come to chainlinks.org, we will see like different nodes. Let's call it nodes for different networks. So if we check Ethereum mainnet, we will see all these RPCs here. And then if I just copy paste the first one and I input that RPC here, we are going to interact with Ethereum mainnet right now. But then if I change this for the Polygon endpoint, we are going to interact with Polygon. So I'm going to show you that right now. So let me just create the function. Get chain ID. So we can use the Web3 library, this Web3 object here, web3.it.getChainID, and then this will return the current chain ID that we are connected. In this case, it will return the chain ID of Ethereum. So let's start that here, chain ID. And then we can render this in the front end by using this use state, set chain ID. Okay, so we are calling web3.eth.getChainID. We are storing the result here in this chain ID variable, and then we are just rendering the front end by using this set chain ID. We have a lot of different methods in Web3.js that you can use. Like get balance will get the balance of a specific account, get block number will just return the latest block number, etc. But let's just use the get chain ID. Okay, and then this chain ID will call the get chain ID function. So far I just created this button that is interacting with this get chain ID function, and this get chain ID function is actually getting the current chain ID that Web3.js is connected. And Web3.js is connected to Ethereum mainnet, so the chain ID will be 1. So if I show you this here, and then I click in chain ID, we are getting a 1. But then if I change the RPC endpoint to interact with base, and then we click again in chain ID, we are getting the base chain ID because now we are interacting with base. Is this confusing? Do you have any questions so far with this? Just by changing the RPC endpoint, we are interacting with different networks. So if I get the latest block number right now, we are getting the latest block number of base, not of Ethereum, because we are connected to base, right? So any questions so far with this initialization of the Web3 library? Okay, so normally this is used more in the scripts or backend, but if we want to actually be connected to the MetaMask of the user, like in the front end, we need to type window.ethereum. And then this window.ethereum will be connected to the network that I have connected here in my front end. So if I connect my MetaMask to Ethereum mainnet, and I click in get chain ID, we are getting 1. And now if I change to Sepolia, and then I click here, we are getting the Sepolia because now we are connected to Sepolia. So this is how we can use Web3.js to play around with different networks in our front end. Any questions so far with this? Normally, if you are doing dApps, you will always use window.ethereum. You will not use the RPC endpoint, the string that I show you, because that's just hard coding RPC endpoint, and normally we don't want that. We actually want window.ethereum, and maybe ask the user here. We can have like a if and then an alert to say like, hey, if my contract is in Sepolia, we need to say, please connect to Sepolia. Because if you try to call my contract connected to Ethereum, you will get an error because my contract doesn't exist in Ethereum. It's in Sepolia. So any questions so far with this?
I think now that we are from where the RPC endpoints are, we could illustrate how to onboard a network to my MetaMask wallet. Let's say I just installed MetaMask and I don't have this network in MetaMask.
Oh, that's okay. We can even do that in the dApp, but it will be more complex and it will be a lot of code. I can show you. I created a plugin for that. Let me just show you really quick. He's trying to ask like how, if I am a new user that just have MetaMask, you will not have all these networks here. You will only have Ethereum, Sepolia, and a couple more. So how can I onboard my user to Base if I have my contract in Base? That, for example, there is a button that says connect to Base, and then you will add the Base network in your MetaMask. I will say that the fastest way is to ask your user to come here, and then you can click in add to MetaMask, and then MetaMask will pop up, and now you will add Base to your MetaMask. That's how you can do it. But then if you want to do that in code, I have this plugin that I created that is called Web3 MetaMask plugin. And then if you call this function, let's say switch to Ethereum, this will pop up MetaMask to switch to Ethereum network. Or if you use this one, switch to Sepolia, it will switch to Sepolia, or add Sepolia if you don't have it there. I only implemented these networks, but you can implement Base, and then you click in, you call a button that calls this function, and then it will change that to that network in the front end. So yeah, it will basically do that. But yeah, that's a little bit more code that I don't want to include today. It will be too much. So yeah, so far you guys understood this concept of window.ethereum and then the chain ID we are interacting with different networks just by putting this window.ethereum. So that's why I say this is the most important line of code, because this is initializing the Web3 library, in this case, to MetaMask. Yeah, you will always need to initialize the Web3 library with a network. If you don't put anything here, because we have this under the hood by default, Ethereum mainnet. So if you leave this empty, you will be connected to Ethereum. Right now, if I leave it like that, and then if I click in chain ID, oh yeah, we have one, because by default we have Ethereum mainnet. Then if I put a window.ethereum, then we are connected to Sepolia again. More questions before we interact with the contract? Perfect. So I will just delete this. We don't really need that. That was more to show you an example. Okay, so far the only things that I have done is importing the Web3 library, importing the ABI, and initializing the Web3 with window.ethereum. Now we need to initialize the contract. So to initialize the contract, we need to type new Web3. We always need to use this Web3 object here, .it.contract. And then when we open the parentheses, we will see that this receives two parameters, the ABI and the address. So the ABI is already here. And then the address, I already put the address here in the README. So this is the address of our contract, here. Any question so far with this line? I'm going to store this in a contract variable, contract instance, let's say contract. And now to interact with the contract, we will always use this instance of the contract. So the only thing that I did, new web3.it.contract, this will receive the ABI of the contract and the contract address. And now let's call the contract. So remember that the call function, the reading function, is called getMessage. So let's implement the function. So to call the contract, we only need to type the contract instance, so contract dot methods dot the method that we want to call. In this case, the method that we are calling is getMessage. So it's the name of this Solidity function, getMessage dot call. This is how we can call reading functions in smart contracts. Let's say that we are calling other reading functions. Let's say that we have an owner. So if we want to get the get owner, it will be like this. Or depending on the name, maybe, I don't know, any other function can be name. When you are interacting with ERC20 contracts, they have a function that is called name, and this just returns the name of the token. So this is how you can interact with contracts with reading functions. The contract instance dot methods dot the method that you are calling in the Solidity contract dot call. Any question with this so far? Remember that we are using this contract instance, but then if I change the name here, let's say my contract, then we will need to use this my contract instance. Yeah? No questions so far? So this will return the current message, right? So we need to store that. Let's say current message. And then what we can do is that we can render that in the front end. Maybe let's put some comments. Call contract and render front end. Then to render the front end, we need to create a use state again. Const message, set message, use state, no message. So by default, this will be no message. And then let me show this here. Message. Okay, and then our front end, get message, then message, no message so far, right? And then here in the get message function, we are going to render that in the front end. So set message, that is the name of my use state here, will be the current message that we receive from the contract call here. Any question with this one so far? Perfect. Then what we are going to do now is actually to connect this button get message to the function. Then the function is called get message. And now let's click there. So if I click in get message, we are getting the third message that is actually what we have here. Third message. And if I update the message, let's say for message connect, we send this aggressive, and then we wait maybe 1 minute, and then we get the message. We'll get the for message here. So any question with reading functions in the smart contracts? We are having food soon, I guess, right? Yeah, in a few minutes after we finish this. Okay, so this is how we interact with the contracts. If I click in get message, okay, now we got the for message because it was already updated. Perfect. Now it will get a bit more complex because to update message, we need to connect an account. So remember, for interacting with reading functions, we don't need funds. Like every time that I click here, I'm not spending money. This is free. Fetching the message from the blockchain is free. We don't need funds. But then to update this message in the blockchain requires funds. And then if we are paying that, we need to connect an account to be able to pay for those transaction fees. So what I need to do is first to connect the accounts and then to update the message. So now you are going to learn how to connect an account. So I'm just going to, yeah. Yeah. Oh, no, if you are going to send transactions, you always need to connect an account. If you are testing, then you use testnet tokens in a testnet. But you always need, yeah, because then if you can update the blockchain without sending transactions, can you imagine everyone in the world sending transactions for free? The blockchain will collapse. But then that's the point of the transaction fees. Because then if we are sending transactions, it will get higher and you pay more fees, or you just don't interact with the blockchain. Yeah, that answers your question. Yeah, only to fetch data, we don't need any money. We don't need any wallets. But then to update the data, to write in the blockchain, we always need funds. Always. Even if, in this case, testnet accounts. Any other questions? Okay, so now let's play around with this other function. I'm going to create two functions. One will be connect MetaMask, and the other one will be to interact with the contract, update message. So in this connect MetaMask, maybe let's have a new button as well. Okay, so I just added this new button that will connect to MetaMask. So when I click here, MetaMask will pop up and will ask me to connect one account. So to do this, it's also one line of code that is web3.eth.request accounts. So just by calling this function, MetaMask will pop up. You will see that. And this will return an array with all the accounts that I want to connect. So let's say accounts, await, web3.eth.request accounts, and I'm just going to console log the accounts here. Let's say connected accounts. Okay, so what I did new was to create this connect MetaMask function that is just using web3.eth.request accounts. This will ask MetaMask like to pop up and ask me to connect my accounts, and then I'm just going to print that in the front in the console. First, I will disconnect my accounts because I think, oh, okay, oh yeah, it's connected. Disconnect. Okay, so if I click in connect MetaMask, let me open the console where I changed. I forgot where to change the order. Oh yeah, here. Okay. So if I click in connect MetaMask, MetaMask will pop up and will ask me to connect the accounts. So I can connect these three accounts. I click in next, confirm, and then we see the array with the three accounts that I just connected, right? In this case, I will just disconnect all of them because I will just need one. Disconnect all accounts. Then connect accounts. I'm going to interact only with this CUEA address. And then we can access to the address of the user, we only have access to the address. We are not having access to the whole account or the private key. We cannot interact with anything, but we are only having access to the address because we will need that address to specify who is sending the transaction when we interact with the contract. So let's return here, return accounts. Okay, and then here we are going to call that function, connect MetaMask. And remember that this will return the accounts. And maybe just let's just return the latest account. Yeah, so what I'm doing is just returning the first string, the first address that is connected from the user. And then we are going to use that account here. So here I show you how you can interact with reading functions, right? But now I'm going to show you how you can interact with writing functions, which is really similar. I just put this for reference, but it will be similar. We also use the contract instance, which is my contract, dot methods, dot, in this case, is update message. Let me just double check. Oh, it said message? Oh, no, it's update message. I mean, to verify, we can check the ABI. In the ABI, we have update message, yeah. So that's update message. And then instead of dot call, we need to put dot send. We open parentheses, we open curly braces, and then we need to specify who is sending this transaction. So that's why we need to get access to the address of the user. And then the address of the user is this one that we use when we connect to MetaMask. Any question so far with this one? It's the same as interacting with the calls, but the difference is that we need to specify this from, and instead of dot call is dot send, because this account is the one that is sending the transaction. And then this will pop up in the MetaMask and will ask the user to confirm this transaction. You will see that soon. And yeah, this will also return a transaction receipt. I will just put it there for you to see that. And that's just like a whole object with the transaction hash, the from, the to, the transaction fees, etc. We can just print that there. Then let's put this button on click, update message. Okay, something important that I missed is that I didn't send the message that I want to update, right? I'm just going to hard code something here because this update message received a parameter here in the code that is a string, right? A string new message. So let's just put hello. Oh, yeah, perfect. So now this will be the new message. So if I click in this button of update message, let me actually disconnect my accounts. So what will happen first is I'm going to call this update message. This update message will call the connect MetaMask. So will ask me, the first pop-up will ask me to connect an account. Then once I connect the account, the second pop-up will ask me to confirm this transaction, and then we will see the transaction receipt. So let's click in update message. If everything works well, let's see. So I will connect this CUEA account. Next, confirm. Now it's connecting my account. Now MetaMask pop up again, and it's saying interacting with the update message function. I'm going to be aggressive again, and then confirm. And then here we are going to get the transaction receipt. Yeah. So here in the transaction receipt, we can see the hash of the current block, the current block number on the blockchain, some gas price, the transaction the address that sent the transaction, which is the same as I have here. It ends with 94E. We have here 94E. The gas use was this, and some other things. The 2 is the contract address, transaction hash, etc. And then if I click again in get message, we see that the new message is hello CUEA. So that's how we can interact with the smart contracts. With the smart contract, we only have these two functions, writing functions, reading functions. With the get message, now you know how to interact with reading functions. With the update message, now you know how to interact with writing functions. Yeah, now I'm open to questions to go through this code again.
So when you update the message from your account, it changes the actual variable that's stored on
In the smart contract. Yeah,
So what happens if, like,
it's changing this one, right?
so if two people are calling the same function at the same time, what happens?
The one that pays the more aggressive gas fees? That's a good question. Let's see if we can do that really quick. Okay, let's try that. I never done these things, but let's see. I'm going to pay with one account, and then I will send with a really slow gas fees, and then with the other one later, more aggressive. And let's see if something happens. Oh, but then I will need to update the front end. So I will say hello CUEA 1, update message. This one, confirm. Then I will put low. Future transaction will queue after this one. Okay, confirm. Okay, now I will update this, CUEA 2. I will disconnect the accounts. And then I will connect another account. Yes. Oh, I don't know what it is. Oh, because it's already pending. Okay, so it's not allowing me. Okay, if I deploy this, it will allow me. So we can actually do that. Okay, another thing that you can learn today is, okay, now I have this dApp, and I want to deploy this to the real life instead of having this running on my local host. So something that I did when I was learning blockchain and having creating my portfolio was deploying the dApps on Flick, or you can deploy on Vercel or whatever, but I know this one. Because when you're, oh, let's see, I have something here. Oh, maybe let's see if it allows me to do it. Maybe it was already updated. Oh yeah, it was already updated. That's why it allows me to do it. But we can also try this from the Block Explorer instead of the dApp. But let's deploy the dApp first, because if you learn how to deploy this, then you will learn the whole thing of the smart contract, create the front end from the smart contract, and then deploying the front end somewhere. So maybe a recruiter, a friend, or whatever can interact with our dApp. So I came here to Flick. I create an account. I just log in. I click in deploy your site. Okay, first thing is we need to put this code on GitHub. So let me just deploy, push that to GitHub. I think it's this one. Oh, yeah. It's this one. Oh, yeah. Let's see. So let's say workshop. So I'm just creating a repository for this app. Okay, so I have now all this React app in this repository, CUEA Workshop. Oh, another thing that I need to update, I forgot that, to deploy this on Flick is in my package.json, I need to put this homepage equal to dot. So that can tell the React app what is the homepage. Okay, so now I just deploy this, the package.json here with the homepage, perfect. Now I come to Flick, I click in add new because I want to deploy a new site. I connect this to my GitHub. I need to adjust the GitHub permissions because I just give the permissions to every repo that I want to deploy. Then here I will choose the repository where I have my app. This one, CUEA Workshop, save. Then in Flick, I'm going to select the repository where I have my dApp. Okay, so it's here. Then I click in deploy. This will check the framework, that is a React app. I click in deploy site. And that will take a couple of minutes, 1 or 2 minutes. And then after that, you will be able to access to my dApp and interact with my smart contract with this URL that we will see here. and then the dApp will be there live, interacting with the contract. And yeah, and then that's something, yeah, we can wait a couple of minutes. More questions, if you have more questions. I also have here the whole code if you want to check, but yeah, more questions so far. Can go through the code, the contract, or whatever. Yeah. Is there a way that I want, sorry? To Sepolia. Oh, okay. Several networks, to deploy it in several networks. Yeah, I have a, okay, so when I come to Remix to deploy the contract, there are two things that I need to select. First, the accounts that I want to connect, and second, the network that I'm connected, right? Oh, in the dApp. Yeah, in MetaMask. Yeah. Oh, having, oh, okay, so then, okay. The thing is, this contract is deployed in Sepolia. So if we change the network of MetaMask on Optimism, it will try to interact with this contract address in Optimism. And if we go to the Optimism block explorer and we check that contract address doesn't exist. So what will happen, I'm going to show you that right now, but if we check that contract address in Optimism doesn't exist, but that contract address in Sepolia exists here, right? So if I change my network, let me show you the error in the console. Actually, even only with the get message, we can get the error. With get message right now, we have this new message. We are connected to Sepolia. But if I change to Ethereum mainnet, and I try to get message, we are getting an error that the return values are not valid because we are trying to call in Ethereum mainnet this contract that doesn't exist. So that will not work. Perfect. Any other questions? Oh, yeah. Yeah, with this web3.eth request accounts, it will pop up any wallet that you have connected in your browser. Because I have MetaMask, it's showing MetaMask, but then if you have Phantom or I don't know the other ones, it will pop up that one. Yeah. Oh, good question. I don't know. I don't know what will happen there. That's a good. Maybe it will show it will pop up the one that you have by default. I don't really know. Yeah, good question. Any other questions? Yeah.
Within Web3DS, could I, like, is there a function to like create something like a smart wallet?
The thing is, the smart wallet itself will be a smart contract because the Web3.js is only working in this case in the front end, right? So you cannot really create a whole. You can also have Web3.js in a back end and do other things. There is something called plugins, and you can create your own plugin that can be a smart wallet, but then that will be a different thing. Yeah, just to have like a smart wallet in the front end, that will not really work. Yeah. Any other questions? Oh, let's see if this deploy. Oh, didn't deploy yet.
Okay, so if I shouldn't really like allow users to be able to change all the variables in the smart contract, the specific ones that all the users should be able to access. Or
Yeah, so you want that not the users can update the message.
yeah, like the message.
Yeah, so in that case, then we will need to change the code in Solidity. Here, I think we have this one. And then in the set message, we can have the require message.sender equal to the address that you want to allow. For example, in this case, if I hardcode my address, only this address is able to change the message, no one else. So that will be just to add this little require with, yeah, maybe with another variable here, and yeah, that will be the access control that you can use there. Okay, this is taking a while. The- I think it's the same. I just know Flick. Okay, but then there is one difference. There is one big difference here. So Flick has IPFS deployment as well. Who don't know what is IPFS? So IPFS is Interplanetary File System. And this interplanetary file system can be like another blockchain of a lot of computers in the network. And what they do is that they are storing data. So in this case, if I deploy my site on Flick, Flick is deploying my site on IPFS in this network of computers. And then my dApp will be decentralized because this dApp in IPFS will live there forever. IPFS is, let's call it like another blockchain that can store data. And then I'm storing there the front end of my dApp. So the front end of my dApp will live in IPFS. My smart contract will live in the blockchain, and that's a pure decentralized dApp because there's no servers anywhere. The smart contract in the blockchain, the front end in IPFS, and no governments, no people, no one can delete my application, my contract, or my front end. But if I have my front end in a server, that's kind of centralized. That's maybe a difference of Vercel and Flick. Now you can switch to, yeah, I'm just waiting. It's been 6 minutes, and it's a really simple app. Don't know why it's taking so long, but yeah, let's wait a few more, like a couple of minutes. That will work. Any other questions? Perfect. I think, oh yeah, maybe I will stop the recording. Okay, 2 hours and a half.